Hello all, welcome to another quick learning. Today we're going over the binomial distribution in Google Sheets. So the binomial distribution comes into play when you have an event that can cause two outcomes. So for instance, a coin flip, you can either have tails or heads come up, and we are going to simulate it at 1,000 times and show you how to calculate the probability of different levels of those things. So first thing we need to do is simulate the coin flip, and we do that by using an if function. So if we're looking at the rand function, which will give us evenly distributed numbers between 0 and 1. So when we look at less than 0.5, which is the probability of a heads, we're going to label that as heads if it's less than 0.5, and if it's greater than 0.5, the random number, we're going to give it a T for tails. So if we do that 1,000 times, simulation that we did in this particular one, we got 510 heads. So we just used count if to look at those 1,000 simulations and count how many of them are heads. And then tails is just 1,000 minus that because we did 1,000 of these simulations. So if we want to calculate the probability of at least that many heads, so up to 500, so if we did this simulation over and over and over and over and over again, each time doing it 1,000 times, how much of the time would we get 510 heads or less? And that's 75%. And we calculate that by using the binom dist function in Google Sheets. And then we plug in the number of successes that we had, or the number of heads in this case. So that was 510. And we did it over 1,000 different times. And we look at what's the probability of getting a heads. It's 50%. And then we did the true parameter for the cumulative, which just tells us what's the probability of getting that many heads or less. And what that represents in the graph below, so you'll see I have from 400 to 600, this is the number of heads you should be getting in 1,000 simulations, and the percent of time that you'll get that many heads. So if we look where 510 is, 510 is around here, around right here, and if you take the area under the curve to the left of this, you'll get 0.75, so 75%, since the area under this total curve is 1. And the area under the curve to the right of this is 25%, which is the probability that you'll get more than that many heads, which you can use just 1 minus this value to get that, since the total area under the curve is 1. Now, if we're instead just interested in the probability of getting exactly that many heads in a simulation, so what's the probability that we're going to get exactly 510 heads? We're not going to get 509, we're not going to get 511, we're going to get exactly 510 heads. That probability is 2.07%, and you can calculate that with the binom dist function, and instead of putting true in the cumulative, just put in false. Okay. Now, the probability of an event is not always going to be 0.5 for both outcomes. For instance, let's take a football game. Both teams are not going to be equally skilled, so one is likely to be more likely to win than the other. So if we look at, let's say, Patriots versus Bills, the Patriots are a better team, so their win probability is 0.9%, or sorry, 90%. The win probability is 0.9. So if we simulate that 1,000 times, in this case we got 906 Patriots wins and we got 94 Bills wins. So again, we can calculate the probability, and we just by chance got the same, but let's go ahead and force it to calculate again. So you'll see now they're a little bit different. And actually this is very close to the expected number because 0.9 times 1,000 is 900. So you'll see that as we get closer to the expected number right on the top of this curve, you're going to get closer to 50%. So again, if we look at the area under the curve to the left of where our wins total is, that's going to be 60% for 902 and 40% to the right. And the probability of exactly that many wins is 4.15%, so it's right near the top of this curve, which you'll notice the binomial distribution curve changes as the probability changes. So you can see these are different curves. This one doesn't go up as high, it's kind of pushed down and it's broader, so it's got a higher variability. Whereas this one has a higher peak here. You can see these, this axis is not the same, so this is going up quite a bit higher than this one is. And you can calculate the mean by just taking the probability times the number of events that you did. So in this case it's 1,000 times 0.5, which gives you a mean of 500. And the standard deviation is going to be the square root of the mean times the probability of heads, and then times the probability of tails, which is just 1 minus the probability of heads, which so is be 0.5 times 0.5. So it's basically 1/4 the mean, and then take the square root of that. So you do the same thing over here. The mean is 0.9 times the number of times you did it, which is 1,000, so you get 900. So you got the peak of this curve right at 900. And then the standard deviation is lower, so you do it the same way. You take the square root of the mean, so 900 times 0.9 in this case is the probability of a Patriots win, times the probability of the other condition, which is 1 minus 0.9, which is 0.1, and that would give you, so this interior part would give you 81. You take the square root of that, and that's exactly 9. All right, so that's how a binomial distribution behaves, and you can calculate the different probabilities with Google Sheets. All right, I hope you guys learned something, and you guys can now calculate probabilities of things that can occur with two outcomes. All right, thank you very much. Bye.